Hello everyone and welcome to today's pre-activity classroom, which is for third year undergrad students in course Introduction to Security. So as you know, we follow a flipped classroom model in which the students are supposed to grasp essential information that help them to indeed understand and do better performance, or let's say do some practical later in classroom session. So there are some prior knowledge assumptions, including students are familiar with some initial concept of database, create, read, update, deletion operation. They have some basic knowledge about web application design, let's say client-server interaction. And also students have been exposed to initial cybersecurity knowledge, such as authentication, access control, but not very deep knowledge about any attack. To understand how, today I will discuss about SQL injection, but before that one, to understand why it's important, I will talk about OWASP top 10 list. So OWASP, which is open source community for curating the cybersecurity attacks over the, say, softwares, over the web application servers, have listed SQL injection in its top 10 list from its inception. So essentially it's important for us to understand what is this attack and how we can indeed prevent using some techniques. Here you can see an example of web application architecture in which the user or client communicate with web server through the different web pages, and then web server communicate with app server providing some information, and then business logic, which is located in app server, just create a SQL indeed query and then pass it to the database server to fetch the corresponding information. Let's say we have a login page in our web application server which requesting user and pass from the user. The legitimate user Alice provide its username and then password and then push login to get into the login page, right? What happened in the backend is that we hold the user and pass into two variables, un and pw, and then for building the query string, we concatenate these variables, saying that SQL select star from users table, where username is equal to concatenate the un, and then and password equal to concatenate the password. So what happens here is that SQL Server goes through the users table, compare the username, compare the password, take out if they were matched, and then provide to the upper layer. One technique that a malicious user can perform to attack the database, or in general our system, instead of providing the name, it provides, let's say, root admin whatever, and then a closing quote, and then dash dash, and then hit the login. What happened in backend? When we are concatenating the received input from the malicious user, here we put in root and then closing quote and then dash dash. Dash dash is a special notation or symbol for SQL indeed dialect, for SQL language, saying comment out the rest of the line. So we can then simplify this command into this command, saying selecting a star from users table where username is root without checking password, right? Therefore, SQL Server search for user root, fetch the corresponding line, and providing information to the upper level, right? That might redirect the illegitimate user to the root page. We are granting unauthorized access without appropriate checking indeed that happened as a result of SQL injection. The next technique is that the attacker provide an always true command. Here, closing comma, closing quote, or command, and then 1 equal to 1, which is always true, and then comment notation. What happened in backend? We have a null username, which is then combined with or command, which this side of the command is always true. Therefore, this part will always result in true and then comment out the rest of the line. We can simplify the whole command into select a star from users. There might be capabilities to send back all information. That is an example of data leak. Or it can send out the first indeed line of the table that normally corresponds to some administrative users in our system. Again, unauthorized access, data leak, which are not supposed to be in our system. The next technique is that the malicious user exploit capabilities of some database servers. So some database servers have the capability of running batch command execution, which are separated using semicolon. So in this case, the attacker provide a closing code, then semicolon, then drop table users, and then dash dash. What happens in backend? When we are concatenating the provided user inputs, indeed we are saying right now, for now, the username is null, but you should execute drop table users, right? SQL Server, first, just check this part, stay here, now it assumes it should indeed execute this command, which is dropping a table. And the rest is commented out. What happens is that the users table will be removed from our database, which is modifying data, removing data, altering data. That is not supposed to be available in our system. There are a couple of techniques in the community which is commonly used, such as parameterized queries, prepared statement, on mitigating or by validating the input and also sanitizing the input. To check the first technique, parameterized queries plus prepared statement, in this technique, here you can see an example of Java in the language. We have two components in this technique. First one is the indeed parameterized query. Instead of concatenating the user input, we come up with the whole SQL command, but instead of user input, we are putting some parameters. Saying SQL Server, you should receive some parameters or replace some parameters here. And then we extract those parameters using prepared statement. Then we pass these parameters to our query. What happens on the SQL side is that when we are including these indeed input values, these values are behaved like a simple text literal, right? Assume the malicious user is providing a dash dash as a username. What happens is that SQL Server goes through the rows, search for a line which username is equal to 1, 1. If it cannot find, it then returns null, right? We are removing the command execution effect over our database. The next technique is user sanitization and validation. We can build different lists and then compare the user input against this list. We can have a black list. That means we don't expect the notations such as dash dash, such as semicolon, such as slash, backslash, these sort of indeed characters. And then if the user input has these characters, then we can skip those parts or sanitize, then validate and provide to the database system. The next technique is to have some allowed list, or let's say white list. If we expect the username is an alphanumeric value between 1 to 20, then we can enforce both front end and back end so that the user input be matched and it doesn't accept any input which is not aligned with our policy. So in the community, whitelisting is more common because blacklisting might not be complete enough, right, whenever a new technique happens, or it might not be matched to the specific SQL dialect, right? Therefore, whitelisting is a more common technique, less vulnerable to SQL injection. So I will upload a code that is vulnerable to SQL injection for the students into the system, and then in our next in-class session we will go through this code, analyze it, practice identifying vulnerabilities which is included in a simulated environment. Then we used a couple of techniques we talked today, and figure out which one can appropriately, or let's say more powerful, can address this indeed SQL injection attack. Thank you everyone for watching, and looking forward for our in-person session.